Hello, fifth graders. Welcome to lesson 6.3, Justify Multiplication as Scaling. Let's get started. Today's objective is I can justify the scaling of fractions by explaining if a product of a fraction will increase or decrease without calculating, with 100% accuracy in multiple attempts. Please pause now to type the I can and by statement in your digital math notebook. All right, friends, we'll start off with me giving some examples. The I icon means that this is not in your digital math notebook. You're just watching me for a moment. For the last couple of lessons, we have been talking about multiplication as scaling. Today, our goal is to justify our answers. That means that we need to be able to explain, prove, and show that our answer is correct. So without solving, we're not going to do the math. We're just going to use our reasoning to match each fraction to the correct equation. So the first thing I notice is that 8 over 8 is equal to 1. So anytime I multiply by 1, remember that it's going to stay the same. So I'm going to go look for a problem that stays the same. So I have 7 and 2 2/3. That doesn't stay the same. 9 and 12 3/5. That doesn't stay the same. And 6 and 6. Perfect. So this is going to be 8 over 8. All right, my next answer is 1/3. So 1/3 is smaller than a whole because 3/3 would be one whole. So I'm going to go look for a product that got smaller. So I know that from 7 to 2, that got smaller. So that must be 1/3. And lastly, 7 is greater than 5. So that means if I multiply by greater than one whole, my number should get bigger. And from 9 to 12 gets bigger. So 7/5 goes here. All right, let's keep practicing this. I have 3 and a 2 1/10. So that got smaller. So let's go look for a fraction that is smaller. 7 is smaller than 10. So that means that it is less than 1. So we know that that can be this one. All right, next we have 2 and 2. So that stayed the same. So we're looking for a fraction equal to 1. So that would be 5/5. And lastly, we have 8 and 18. So that got larger. So we're looking for an example where the numerator is larger than the denominator and 7 is larger than 3. So 7/3 goes here. This should be review. Let's keep practicing together. All right, this is in your digital math notebook, and this is where we really get into the justifying. We need to be able to tell someone else why we know our answer is correct without multiplying. So our question says, what missing numerator would make this inequality true? An inequality means that we use these alligator symbols. So remember that the alligator faces the bigger number. So we're saying that whatever the result of this is going to be greater than 7. So we need a numerator that's going to be greater than 5 so that my number gets bigger. So let's see, there's lots of answers that could go here, but how about 7? So 7 over 5 is greater than one whole. So I know my answer will be greater than 7. So now we need to explain, how do you know? And are there any other numbers that would make this true? So we can say 7 is greater than 5, which means it's more than one whole. And let's answer the second question. Is there other numbers that could make this inequality true? Of course, I could use 9 over 5 or 11 over 5 or 17 over 5. So yes, any number more than 5 would work. Now, you don't have to copy down my exact words or my exact number. You could use a different number in your example in your digital math notebook, as long as that number is greater than 5. Let's try example 2. What missing numerator would make this true? All right, so we have 11 and 11, so it's going to stay equal. So that means that we need to multiply by 1. So we need to look, our denominator is 6, so in order to make 1, our numerator would also have to be a 6. Now this is a case where, are there any other numerators that would make this true? No, the only way to make one whole would be 6 over 6. So let's explain, how do we know? So 6 over 6 equals 1. And 1 times 11 equals 11. So that's how we know that we're correct. And are there any other numbers that would make this true? No. Only 6 would make this true. Great job so far. All right, 5th graders, it's time for the lesson activity. In the lesson activity, you're going to complete some problems like we just did, where you're finding the numerator that makes the inequality true. We'll start off together. The first inequality sign has the alligator facing towards the 8. That means that this is going to be less. So if we think of less, we're going to get smaller. We need a number less than 3. So 1/3 would do the trick, or 2/3 would do the trick, but 3/3 would be too much because that would be equal to 1, and anything more than 3 would make it get larger. So it has to be less than 3. All right, how about the next one? We have an equal sign. So in the equal sign, that means it has to stay the same. So our denominator is 10, so our numerator also has to be 10. Oh, sorry. 10. There we go. All right, so that's going to equal to 1, and your job is to finish this last box on your own. Notice that the alligator is facing towards the equation, not the 6. So that would be a greater than. So that means that that number in the box needs to be greater than 12. That could be a whole bunch of numbers, so you decide. Great job, 5th graders. When you feel comfortable with this lesson, complete the exit slip to show the teacher your understanding. Great job.